Oh, hey, she's here. Great. Hey, Fabliha.
Hello, Professor. I'm
Hey.
really sorry to be just on time.
No,
I
no, no,
hope I'm
no
not
worries,
really
no worries. Yeah.
okay. Yeah, great. Good to
Wonderful.
see you all.
Yeah, great. Looks like we can start on time. So, Matt, you want to say a few words to help kick started this group?
Yeah, sure. So I could say some kind of really quick stuff. Yeah, so the topic of discussion today is going to be this paper, the next generation of BGP data collection platforms. This was a paper that was presented in SIGCOMM 24 in Sydney, Australia. It received the Best Paper Award at the conference. Um, I wanted to start by telling you all a little bit about why I like this paper. So I think one of the motivations for this is that the internet's very hard to run. It's very complex. There's millions of routers, distributed all over the globe. These vast arrays of distributed protocols that make the internet work. The internet's really complicated. The Some people say the internet's the most complex thing that humankind has ever created. More complex than the pyramids and skyscrapers. It's nothing compared to the internet. But so you have these kind of tens of thousands of ISPs and different networks that are kind of, they have to, they compete they're competing with each other, but they also have to work together. So that's kind of what makes this space kind of, it's not surprising things go wrong when that happens. We read about this in the news. We read about kind of, route hijacks and denial of service attacks and people infiltrating and getting into holes and things like that. And, it's really hard to debug these problems just due to the size and scale of the internet. And, one thing that makes it really complicated is you can't see very well on the internet. You can't just like, all these network operators keep their networks private from each other, kind of hidden from each other. And, um, things would be a lot easier if you could kind of see inside, uh, each other's networks, but you can't, the protocols that run in the internet don't, are not designed to reveal information, and ISPs actively, put in things in place to avoid revealing information. And so one thing that's kind of evolved over the years is these kind of data collection infrastructures, looking glasses. Route views is a famous one. It's this data collection infrastructure where uh, it's set up as a router and ISPs agree to peer with it. And this router doesn't actually route packets. It just kind of sits there and logs updates. And so you kind of get these logs of updates and kind of see what you see in them and see where they come from and see what prefixes are being advertised and AS paths and so on. And so we're all very thankful to the University of Oregon for kind of maintaining that. So one reason I find this paper really exciting is that it's innovating on that. And that infrastructure has been around for almost 25 years. And so it's kind of there and it works and it does something really neat. But this paper is kind of, taking a new look at kind of this challenge, and it does it in a really creative way. Uh, so we have the
Awesome.
Alfroy, Thomas Alfroy on the call. Um, Hello, he's going to be here. So I think he's going to ask him questions. Fabliha is going to present. Um, I think what we want to do, and thanks to Chow for organizing all this, and the students, you guys did a lot of work on this, and I appreciate that. I think we wanted to kind of keep this informal, so feel free to, we hope everyone will kind of ask questions and participate in the discussion if you can. And it's hard because this is the first time we're meeting each other, and it's kind of hard to first kick off and stuff like that. But if you guys are up for kind of like asking questions and discussing, that's really helpful. But yeah, so maybe we can kind of read the paper and discuss. And did the paper do what it said it would do? And are there, do we have ideas for future work? Let's kind of discuss. But yeah, anyway, do you want to take things over, Fabliha?
So
Yeah.
before Fabliha her presentation, Matt, how about you and Fabliha open your camera so that we can take a group picture virtually, so that to
Yeah.
add, right? So Let me see. Let's see how we do that. Just give me 1 second. Yeah, I think, oh, okay, great. Okay, say cheese. All right, okay, I already took quite a few pictures, a screenshot, so I will share with the group later. So now that Matt already great opening, and I will more to Fabliha. She's a graduate student at in Bangladesh, and she will present this wonderful paper, which I also like very much. And after the presentation, Thomas, Fabliha, and I will try to start a panel discussion about this paper. And if students have any questions, the audience has any questions, just post it in Zoom or in Tencent meeting or on Bilibili. Just post it, and we'll monitor the chat channel, and I will try to relay the question to the authors, to Thomas later. All right, thank you, Fabliha. It's all yours.
Thank you so much, Professor Cao and Professor Matt. I'm Fabliha Labiba. I'm currently studying at Bangladesh University of Engineering and Technology. And today, I'm really grateful for giving me the opportunity to present this really intricate piece of work. It's quite a detailed and complex work. So pardon my mistakes if I turn things up. So thank you so much. Can I start with it?
Yeah, of course, by all means.
All right. Thank you so much. So here we go. Right.
Yeah, we already
May
can
I
see your
have
screen.
a minute?
Yeah. Of course. Of course.
There we go. Okay, so today I'm here to talk about the paper, The Next Generation of BGP Data Collection Platform. It was awarded the best paper at SIGCOMM 24 conference. I'd like to start with the basic of networks. Like what we can see right now on the screen is a very simple network topology here. Like every device is connected to the same computer network, and they can use local network addresses to communicate with other devices. For example, if node A wants to communicate with other devices like to node B or node C, it can just do so directly. But once an organization has more than one such simple network or like more than one local area network, it needs to connect all of the devices or all of the local area networks together. So for example, if node A from one topology wants to connect with node M, we are going to need a routing. So
Hello. Fabliha, is it the connection? We can see your screen, but we couldn't hear you. Yeah. Hello,
Professor,
Fabliha?
am I audible?
Yeah, yeah. Now we can hear you. Yes, I think we lost your voice for about 10-15 seconds. Yeah, go ahead.
Okay. Apologies for the disruption. So as I was saying, like large organizations and like most internet service providers manage internet connectivity for multiple network sites and like for multiple locations. So this is what we called an autonomous system or an AES. So while networks inside an autonomous system handle routing for their own local traffic, a router directs all inbound traffic into the autonomous system and all outbound traffic going to the internet from inside the autonomous system. So basically speaking,
Oops.
The internet information.
Oh, go ahead. Go ahead. Sorry.
Am I audible, Professor?
Oh, yes, we can. Yeah. We can hear you. Yes, please.
Okay. So I was saying, for complex network information, we need something that can tell us the path to route it. Here comes BGP. Thanks to BGP, Broadway Gateway Protocol is supposed to be a routing protocol used to exchange routing information between different autonomous systems on the internet. And it determines the best paths for data transmission across the network. Much like a post office processing mail, and in this case, BGP picks the most efficient routes for delivering internet traffic.
Fabliha, looks like your connection is a little bit unstable. So maybe I think maybe to save the bandwidth a little bit, maybe we can turn off our video. Maybe just leave leave her screen. That's easier for us. Go ahead. I think
I'm extremely sorry, everyone. Am I allowed to, drop the meeting and then rejoin it? I think my internet's unstable. It's constantly showing the message. I think I should just move to another network. Yeah, I'll be in a minute.
Okay, sure. All right.
Yeah.
Yeah, so I guess looks like we still have lots of to do with networking, right? So our community, even with high speed internet, all the like 40 gig, 100 gig, even 400 gigabits per second technologies, but still, speaking from a global perspective, we're still in certain regions or at certain different times or due to different constraints, we still couldn't have very 100% stable available network. So yeah, that means we have lots of to work on. So yeah, while we are waiting for Fabliha to rejoin us, probably will take another minute. So let me essentially try to basically fill in a little bit on the background, right? So essentially, because BGP is the de facto interdomain routing protocol in internet, and it's been there for a long time. And but since we are talking about the internet or interconnected networks, so each autonomous system has their own configurations, their own atomic routing policies. So that means whenever operators in one autonomous system want to configure its configuration, update its own configurations, there is a chance that after the configuration is deployed, there could be some service disruption, right? So we all know that, or some of us probably know, familiar with the non-log mailing list. And also we have something equal in China as well. Essentially all the operators, and they have this close, from different networks, they have close interaction to work together to react to any network, interdomain network failures. But so that essentially makes what can they what data they relies on to diagnose the whole interconnecting issues. So essentially that goes down to collecting BGP announcement at the different networks, right? So hey Fabliha, we see you again. You muted, I think you need to unmute yourself.
Oh, oops.
Okay.
Yeah, so I was saying, yeah, it's suddenly raining here and the network's being a little fussy. Sorry about that.
Sure. No worries.
Let me just share the screen really quick. Right. Is my screen visible to all of you?
Yes, we can see that. Yeah, please go ahead.
Right, great. Okay. Okay, so I guess I'll start with introducing BGP once again. So here we have our border gateway protocol that is basically the routing protocol used on the internet that facilitates the exchange of routing information between autonomous, and it determines the best network routes for data transmission. And as I was saying, which is some sort of similar to how a postal service calculates efficient delivery routes for mail. Moving forward. Okay. So BGP data is something really important or crucial for enhancing, say it be a network security or optimizing performance or enabling effective troubleshooting by providing insights into routing behavior and topology across the internet. As we can see here, I've attached some screenshots that speaks for the importance of BGP in network industry. There we go. So border gateway protocol is used to exchange routing information between different networks, and it actually helps by making decisions based on paths, rules, and policies. Now, in such a complex system, here we come to introduce the problem, the issues we are facing. So here I've said that it can generate large volumes of redundant BGP updates. Now, a BGP update is a message sent in BGP peers that communicates changes in the routing information within the network. And these updates are essential for maintaining the accuracy and the smooth data flow routing across the internet. So here's the challenge. Since we're producing massive amount of redundant updates, we need to have better coverage with less data, which means we have to find a way to tackle with this redundancy in order to have a smooth operation throughout. So here we have the current systems. We have the existing BGP data collecting platforms, route views, and RIPE RIS. So as it goes, like many updates from various peers or autonomous systems are similar but not identical, which leads to redundancy. And that causes wastage of storage and processing resources. So as a result, unique routes and anomalies such as BGP and link failure localizations, these often go undetected, with the number of autonomous systems exceeding 75,000 and over 1 million announced prefixes or IP addresses. The growing complexity of the BGP ecosystem are introduced as issues. And consequently, users frequently resort to sampling methods to manage the vast amount of data collected while striving to retain the essential or the crucial insights. It's really hard to cope up with the increasing growth of such numbers. Okay, so here's the first observation. So this is a visualization of how local views from different vantage points help to map the topology of autonomous systems on the internet. Like the figure A shows a scenario where multiple links between different autonomous systems are visible. And the figure B shows like how some links might not be visible from certain VPs. And here in figure C, we can see that the views from different vantage points might be useful, but at the same time, a lot of links could go invisible as well. And here's another observation. So this figure shows like more and more vantage points are being added over time to help collect data on internet routing. But because the total number of internet networks or the autonomous systems is growing so fast, the overall percentage of autonomous systems that have these vantage points is not increasing much. So the vantage point is basically the this top where we can get the insights and data of the route or the data traffic flowing path. Moving forward, okay, these figures show that the BGP updates that help how data moves across the internet have grown a lot over the past 2 decades. This means that there is much more data to process now than before, making it harder to handle, but also providing more details into how the internet works. Okay, so as we were talking about so much redundancy and so much increasing of BGP updates, the current, the existing platforms are covering only like 1% of these vantage points or the information about the autonomous systems according to the data. And this figure is suggesting that the ideal situation would be covering at least 50% coverage for optimal insights in order to have a smoother operation all around the network. Okay, here we come to the redundancy in BGP data. So defining redundancy, there's like 3 definition: on prefix-based, on prefix and autonomous system path-based, and on prefix and autonomous system path and community-based. So in all of 3 categories, we can see that the redundancy rates are quite high. So it's not something that can be avoided that easily. So all in all, we can say about the problem is that the current ways are somewhat suboptimal, gathering redundant data while potentially missing critical parts. So scalability or the ability to effectively manage and analyze the rapidly increasing volume of routing information as the number of autonomous systems and announced prefixes or IP addresses, it continues to grow, which is a concern. So as the network expands, ensuring scalable solutions is crucial for handling this complexity and ensuring reliable network operations. So here's come the solution GIL. So the new paradigm GIL, it offers deployment of a new BGP peering system that automates the expansion of vantage points, which scale more effectively, and overall we can get an optimized data collection. The GIL platform is shown to significantly improve to these phenomena, which are to detect BGP high, map the global autonomous system topology, and localize link failures. These important phenomena in network. And GIL also offers peering with 50% of autonomous systems. It would triple the number of peer-to-peer links observed and reduce undetected hijacks by 33%. This is what GIL predicts according to the recent data. Okay, here comes the important part. What is exactly the approach of GIL? So it comes in 2 major points that goes as overshoot and as skirt strategy, and as well sampling algorithms that maximize fairness. So the authors propose their solution, a system that collects a huge amount of data, but at the same time, it filters out redundant information while also focus on expanding the vantage point coverage. So the vision is that to overshoot BGP data collection by deploying vantage points, but most importantly, gathering a lot of data to prevent missing important information. And after that, discarding the redundancy by filtering out the redundant BGP routes to reduce the volume of data collected. And if they can automate the process of peering with networks, they can greatly increase visibility and reduce blind spots potentially. However, it can be said that it's only possible to scale up if they can efficiently discard data, which are less unique. Okay, so to do this whole thing, it calls for a system or an algorithm that identifies whether two BGP updates from different vantage points are redundant or not. That's the whole point. So am I audible?
Yeah, we can hear you. Yes. Fabliha, we can hear you.
Yeah,
we can
Professor,
hear you.
Yeah, can I share my screen once? It sort of froze, like it won't
Oh, yeah.
proceed.
Sure.
Right. Okay. Just a minute.
I think I also read the paper while we're waiting for Fabliha. So I think that the fundamental approach taken by Gil is this so-called overshoot and discard strategy. I think that's a very reasonable and a very surprising insight. I think in the paper, Thomas and other authors make the analogy as the Large Hadron Collider, right? So basically, how do they do this all kinds of high energy physics experiments, and there the huge amount of data are generated in a very small, within very small time interval. But they essentially CERN couldn't have the capacity to store all of them. So they use this streaming algorithm and all kind different streaming algorithm to filter out most of the data. I think there's an article saying that only less than 1% of the data collected harvested by the Large Hadron Collider is essentially analyzed by the physicists later. So essentially, I think this, and I personally find this analogy very interesting. And so Fabliha, I think you already reshare your screen. You can continue. Yeah.
Yeah, thank you so much, Professor. Okay, so as I was saying, this whole system of overshoot and discarding and the collecting data from as many vantage points as possible and then filtering out, we need a system or an algorithm that can actually identify whether the two BGP updates from different vantage points are actually redundant or not. So this would involve taking these parameters. Let's write it. I'll just need to remove this from here real quick. Okay. Here we have the parameters that are crucial to identify the redundancy, which goes as the autonomous path, the route taken through autonomous. We have the prefix or it's about the IP addresses, and then some other attributes. So basically, the idea is that if usually the data are not quite identical to each other, but they are very similar. So what Gil is approaching to do is that Gil would identify whether two updates are similar. If they found to be similar, Gil would remove one of the similar update from the storage and leave the other one. So that's how pretty much is it. Okay, now to validate all these and the whole system, the whole idea, simulations are conducted, and they are conducted using these two types of topologies. Automation, yeah, these two topologies. So the AS topologies. One is pruned known AS topology, and the other one is artificial topologies. So the pruned unknown topology is based on CAIDA's AS relationship dataset from October 2023. So this was a bit of info, and the artificial topologies, they were generated using the hyperbolic graph generator, which are actually aimed to measure, these two topologies are measuring three different tasks, which are, we can see the topology mapping, the link failure localization, and the forged origin hijack detection. So the forged origin hijack detection is basically the measure how many of these attacks were detected from the collected routes. And here we go, moving forward. All right. So GIL is the system that is designed to handle large amount of BGP data from many vantage points, and at the same time to improve the coverage while managing the complexity of data collecting and processing. It is done with these two major pathways, which is to overshoot and discard, to collect as many data as possible so that no critical data is missed, and then filter out by checking if they are similar, which is done by the sampling algorithm system. So let's talk about the sampling algorithm system a little bit more. So finding the redundant BGP updates is the key, and then identifying anchor vantage points, or the key vantage points that's actually providing the unique BGP data. Okay, so here we go. The finding to find the redundant BGP updates, we have several steps, which is the grouping updates, the reconstitution power, and then the redundancy across the prefixes. So grouping updates is somewhat a bit of calculation, and the reconstitution power, what it means actually that uh, when checking if a set of updates can be reconstructed from a subset, because these redundancies have similarity among them. So in case we are in need of a particular update that has not been there, we can actually reconstruct it from another BGP update that is similar to that one, the previous one. And then about identifying anchoring vantage points, it's like picking the important or the key vantage points that actually providing the unique data, like path changes or outages, etc. Yeah. So here we come to the GIL's filtering mechanism. The filtering process, as it's been seen, that the filters classify incoming updates as matched. So it could be redundant one. So to be matched to check if it is similar in order to be filtered out. And here's the default policy, like matched updates are discarded, like if they are similar, if there's some sort of similarity, while the unmatched updates are processed and forwarded as new data. So yeah, these actually reduces the workload on BGP daemons, like the software part that we'll be reaching later. Okay. Right.
Yeah, Fabliha, you can continue to continue your presentation. Yeah.
Yes, Professor released. Just a minute.
Yeah, if you feel you want to skip one or two slides, that's also okay. Don't worry about that.
Yeah, I'm really sorry about that. Let's just try it. Okay. All right. Yeah. Okay. So yeah, we were talking about the GILS filtering mechanism. Moving that. Okay. So about the filters, there's a necessity of keeping filters accurate over time, which means we need filter refreshing frequency. Like GIL refreshes its filters every 16 days to maintain accuracy. This is done to prevent redundant updates from being stored over time, and also using experimental data from like 2023, GIL measures how well the filters discard redundant data updates over time, and as time passes, fewer updates match the filters due to new updates entering the system, as we can see in the figure. And about Anchor VP refreshing, GIL updates its list of Anchor VPs once a year, as yearly comparisons of redundancy scores show minimal changes in VP redundancy, ensuring filter accuracy. So basically, GIL creates filters to discard redundant BGP updates while prioritizing updates from anchor or key vantage points. Filters are refreshed every 16 days to maintain accuracy, and anchor VPs are updated annually. Thus, the whole system ensures new updates are captured and provides the flexibility during high traffic periods. Okay, so redundancy over time. GIL needs to discard future redundant updates, but it can't really predict them exactly from the history data. So here's the thing. GIL actually uses the redundancy score difference. That is the same thing to measure how similar BGP updates are between two time periods using the history data. Okay. Okay, so here are the software components to in order to conduct the whole system, we need these software components. One is the BGP daemon, which is basically the C programming, and then there's the orchestrator, which is basically the Python. And all the figures here that is mentioned, the data mentioned here are only on the basis of, so these are changeable depending on the future aspects. Okay, so here comes about the prototype. So GIL is actually running a prototype which is all about collecting BGP updates from like routers that automatically connects new routers and process the data from its own peers and external sources like the existing ones, the route views or the RIS. And then we have the BGP routers and sessions. It's all about the new routers that are joining, that will be joining Gil by filling out a form, and Gil sets up the session automatically. And they also have a two-step authentication process to ensure security and verifying ownership. Okay, so, and here comes another aspect, that is the sampling and filter approach. Now, the challenge here it is to handle large amounts of redundant data. And the solution that Gil offers is using filters to discard the redundant updates and only keeps uh, the rest of the relevant updates. So here's some use cases and results of Gil's sampling, like the key scenario for MOAS detection, where 95% detection was possible, and then also the AS topology mapping scenario was also tested. And then there's some results that Gil actually was able to outperform the naive methods and balancing data reduction while retaining the critical information. So Gil's sampling is effective in order to avoiding overfitting and providing scalable data processing. Okay, so here comes the long-term impact of Gil. So we can talk about the baseline comparison. Like here's the, okay. Yeah, here's the best cases and the smart sampling features. Then we have the simulation results. The like 4.4% of updates were possible to retain at like 100% coverage, and with comparison to existing methods, Gil can process 25 times fewer updates, and it detects 18% more hijacks. And the benefits that are immediately been showing is that 16% of more AS relationships have been possible, and it's improving the AS rank accuracy, and of course the better hijack detection. Okay, so here's some future work for Gil to consider. There's custom services, and then there's collective action, the community-driven initiatives, and then also Gil is thinking about addressing fake peering sessions, where Gil could explore encryption mechanism like BGP over QUIC to secure updates and ensure route validity, and generalizing Gil's approach, which is Gil's method can other types of internet routing data, such as BMP or active measurement platforms, like the existing ones. So yeah, so Gil's feature includes growing its network of peers, improving routing security, and adapting its techniques to broader internet data collection. Okay, so here's what insight I could extract from the paper. I hope I could present a little bit of the insight of what's going on in this really intricate and detailed piece of work. So yeah, Professor, I think we can jump to queries and
Sure.
discussion over here.
Wonderful. Yeah, thanks, Fabliha. I know because this is already our first time, and we apparently we lack a little bit of organization due to the Zoom connecting issues. But still, it's a wonderful presentation, and it's a great paper. And so I think given we'll use the remaining time for the questions from the audience first. So I see Jay post the first question. So Thomas already saw that. So I will just read it to the audience in case someone didn't see that. So the question is, GIL seems very promising, but how can we encourage operators to deploy more vintage points? And will operators be able to glean more insights from the data, or is it really only beneficial for network researchers in terms of data collection size reduction? So Thomas?
Yes. Okay, so thanks for the presentation and thanks for the question. This is very interesting. I will first answer to the second part of your question by saying that, in fact, BGP data is very useful for network operators and not only for network researchers, because whenever there is an issue with their connectivity, for instance, like a failure or they are targeted by a BGP hijack, the network operator, they will have to process this BGP data to really understand what happened and how to troubleshoot the issue. Second, so the first part of your question on how to motivate the network operator to peer with GIL. First of all, I think people are already motivated in peering with these BGP data collection platforms, because we discussed with RIPRIS and route use operators, and they said that they had to refuse some of the BGP vantage point peering requests because of their data management issues. Second, we are also changing the way they set up a peering session. So for instance, right now, they are just sending some emails, exchanging some emails with the BGP data collection platforms. So they are like back and forth, and it consumes a lot of human processing. And I think this can demotivate some of the operators. So with GIL, we automated this process. So if you go to our website, so bgproutes.io, you can just fill out a form where you write your ASN, your IP, you press enter and tag your the BGP session, the BGP vantage points is automatically deployed. So by doing so, we think that this can also motivate operators to set up a peering session. So obviously, we thought about other mechanism to motivate them. So we listed some of them on our websites, but obviously there are still some work to do on how to motivate them to set up a BGP session. So I hope this answers your question.
So Tom, I actually have a related question.
Sure.
Yeah. So I think let me post a sort of like a devil's advocate, right? So I think on one hand, we want to encourage people to peer with GIL, or not, even if not GIL, but with RIPE or RootViews, all those BGP data collection platforms, right? But on the other hand, yeah, I think one of the reasons people want to connect to this data platform is because we share the data and we can work together to identify issues or failures in the internet. But how about privacy? So I think the general consensus people agree on with like BGP is pretty good at hiding things, right? But still, with Li Xin Gao's seminal paper on inferring business relationship between neighboring ASs, right? So we already can pretty accurately infer the business relationship between autonomous systems. And suppose we have infinite amount of BGP announcements data. Suppose we have that, and I think from a program synthesis perspective, isn't it that we can even reverse engineering the configurations of a BGP router or autonomous system? Is it possible? Or I'm asking this because I once looked into this, and I think if someone could try to infer very accurate, detailed BGP configurations using what's available on this data now, would people be less open to share those data? What do you think about it?
Okay, so excellent question. This is actually also a question I had during my PhD defense. So obviously there might be some network operators saying that, okay, so if I send you my BGP feed, maybe you can reverse engineer my traffic engineering setup or whatever other fancy things that network operators can do. First of all, maybe with a lot of feeds, you can reverse engineer. But first of all, I think this is I am not an expert in internal BGP inference strategies, but I think to do this will require a lot of feeds from the same ASN to perform this accurately. However, if you only send one feed, this is already super helpful for the platform, and I don't think this will be enough to reverse engineer what you are doing within your autonomous system. Second, regarding BGP hijacks, because for instance, someone can say that okay, but if I'm sharing my feed, I'm maybe more exposed to BGP hijacks. This is something that I don't think is true, because BGP hijacks, they come from outside your network. So this is not because if you are sharing your BGP routes, this will not help anyone to perform a more efficient BGP hijack, because actually, as I said, it comes from the outside. Like, if I use an analogy, it's like if the professor is asking a question, it is not because you're not raising your hand that you will not be interrogated by the professor. So I think maybe some people will raise some concern about sharing their BGP data policy, even though if I don't think this is the vast majority. And anyways, to be fair, I don't think we will have like 100% vantage point coverage. Like there will always be some ASs that will not share their BGP data for privacy issues, for political, economical issues, whatever. So I think what you're mentioning can scare some networks, but I don't think most of them will. As I said, like all the big actors of the internet, like all the tier ones, are already sending their data to route views or RIS, and all the big content providers like Google, Cloudflare, whatever big content providers, they are already sending this. So I don't think most of the network will really care about this. Not care, you're really worried, let's say.
I see.
So
Cool,
I
cool.
also
Yeah.
see another question for Jay. So for the IPv6 support on the BGP collector,
Right.
so I'm really sorry, but for now, like this is just a prototype that is not super production ready. So it's just running on a small VM that does not have IPv6 support. So technically, I can add the IPv6, but unfortunately, our server does not have a public IPv6 address, so I cannot set up a BGP session. However, you can send IPv6 routes over an IPv4 session. This capability is already enabled in the collector.
Cool. I think Adrian also made a comment that 100% coverage would also not be needed. Would it? He says, right?
Actually, this is something that we showed in the paper, that every single AS in the internet has something very unique. This is something very unique. Even if it's like 0.001%, each AS has something very unique. And thanks to Gil, we are able to isolate this 0.001%. So yeah, I mean, obviously there are some ASs that are more important. I'm thinking about like, for instance, transit ASs, since they are seeing more peering links. There might be more interesting to get. It might be more interesting to get a vantage point in. However, every AS in the internet is interesting. Maybe it's useful at 10%, maybe at 0.001%, but everyone is useful.
Cool. Yeah, wonderful. So I guess we only have a few more minutes left, but since I'm one of the organizer of this activity, I want to because this is more really wonderful education opportunity for students to learn. So I guess I have one question I want to ask is, so as a when you do research, right, you build GIL and you publish your paper, and so one difficulty for students is usually especially when they start their graduate studies, basically how to define or how to find an important problem to work on. So I'm not saying that I know that I'm sure that everyone has their own experience, but I'm asking Thomas from your personal experience, what you to work on? How do you identify, basically overshoot and discard as the correct approach to solve the problem at your hand? So
Yeah, I can give you the story on the idea of GIL because so my former PhD advisor, so Thomas Holterbach, is also present in the chat, and he also we were the two main contributors of the GIL platform. So at the beginning, we were starting to work for BGP hijacks, actually forged origin hijacks. But obviously, to detect forged origin hijacks, you need to process a lot of BGP data. However, while doing all of this, we found out that actually processing all the BGP data is super, super expensive. And so we were thinking, is there a way to actually proceed, to actually find a way to focus only on the most interesting portion of the BGP data? So at the beginning, we were working at the vantage point scale. So how to select the subset of the most useful vantage points, just to focus on the most interesting BGP data, such that our BGP hijack detection system scales better. And after working on this, we said, okay, but isn't there a way to go improve? That would be my advice, because yeah, we were playing with a lot of BGP hijack detection tools at the beginning of my PhD, and then it gave us some idea on how to improve them, and finally it gives the GIL idea.
Yeah, wonderful. Yeah, I think yeah, when I was a student or a postdoc, I wish I had this advice too, I guess. Yeah, that's very I believe that would be very helpful to the students. Yeah, so yeah, since we are I think we are running out of time, and I think any final note or comments to add regarding the paper?
Yeah, thank you so much, Professor. Again, I would like to apologize for the disruptions due to the network. Yeah, it was really great to study the paper and extract the very key points out of it to present. So yeah, it was a really good experience. I got to learn a lot and got to know a lot of insights from this. So thank you very much. It was a great reading session today.
Thomas, I know you were running out of time, but I just found one more question from the audience saying that what's the difference between active measurement and the current approach, like more like a passive approach? Could you help explain a little bit? Yeah.
Yeah, sure. So first of all, I'm not an active measurement expert, so maybe I will not go too much into the detail, otherwise I will may say something wrong. But here, our idea is to study, let's say, streams of BGP updates to identify which ones are the most useful to keep. However, in active measurements, this is somehow quite different because there is no, let's say, pattern in the measurement stream because it's active measurement. So maybe one will start active measurement at time t one day, and then at time t plus 100 another day. So there will not be, I don't really think that there will be some patterns, some redundancy patterns to analyze like it is the case for BGP updates. So here, I don't think the GIL approach will work in active measurements. Maybe it will, but I will not be extremely optimistic. So yeah, I hope this answers somehow your questions.
Okay, I think I'm sure the audience will have more questions, but since we're running out of time, and let's thank Fabliha and Thomas again for joining us, and also for Matt for contributing this Zoom meeting for us, so that we have this we can meet virtually to study this wonderful paper together. And so if you have additional questions regarding GIL, please by all means drop an email to Thomas or Cristel or other authors. And I'm sure I see lots of opportunities and potential of GIL as a next generation platform. I'm very excited about when I read this paper. Yeah, and also before we end, a little bit advertisement about our meeting. So our next meeting will be 2 weeks from now. And we'll send out the announcement official probably next week, because I think Europe and America and United States are changing the times. So I need to figure out what's the exact time slot. And the next, so I believe the next meeting we will study one of the best paper honorable mention at SIGCOMM 24, talking about verification and the reasoning about external routes in wide area network. Please save the date, and I hope to see many of you again. And thank you again, Fabliha and Thomas, and thanks everyone.
Thanks for the invitation.
Absolutely, thank you. And have a good day, good night, or good evening. Thanks everyone.
Thanks a lot.
Thanks.
Thank you.
Bye.